This video will be going over the process of building your Scrambler Champion Kit vehicle. The list of materials and access to all other guides and helpful diagrams can be found on our website under the Kit Instructions page, which is linked in the description below. The first step is to use a small amount of superglue to attach the bearings to the back axle piece. To make the back axle, we need to have a number 10-24 threaded rod cut to a length of 28 centimeters. Next, using a Sharpie, we can mark 4 centimeters on both ends of the threaded rod. Now we can add our components to the axle. So the components we need to add are some hex nuts, the wing nut, the 3D printed brake piece, and some lock washers. You want to add these components to the axle in the exact order shown on screen here. With all of our components attached, we can now slide our threaded rod in between the bearings, making sure that one of the wings of the wing nut is in the groove on the back axle piece. The next step is to secure the axle to the bearings, and to do so what we're going to do is we're going to apply some thread locker onto those markings we made at the 4 centimeters on both ends of the threaded rod. That we made previously. We're just going to apply a little bit of thread locker and then reposition the axle so that the areas we applied the thread locker to are inside the bearing. After letting everything dry, the next step is to reposition the axle components. So what we're going to do is we can first move them by hand, and you want to move 2 of these sets of 2 hex nuts and 1 lock washer all the way to the rightmost end of the axle. And you want to move another set of 2 hex nuts and 1 lock washer all the way to just at the rightmost border of that rectangular cutout you see on the back axle piece. Then using some wrenches we can tighten those 2 nuts together onto the lock washer so that they don't move and can serve as a brake for the vehicle. The next step is to attach bearings to the front axle piece, and this is the exact same process as what we did with the back axle. This next step involves cutting carbon fiber. Now the best method to do this is with a Dremel or a bandsaw. However, because we are making very simple cuts on not very large or thick pieces of carbon fiber, it's very possible to use a basic hacksaw, which is what you can see me doing here on screen right now. For this step, we need to have a 28 centimeter long piece of the 5mm carbon fiber rod to make our front axle. Now, after making this piece, we can sand it slightly using any type of sandpaper you have on hand until it is able to slide easily between the 2 bearings. Next, we can use a small amount of superglue to secure the carbon fiber rod to the bearings. When completing this step, you would like at least 3 to 4 centimeters of carbon fiber rod to be sticking out on either end of the bearing. And after doing so, we can attach 2 of our 5mm bore T61 hubs to the carbon fiber rod ends. The next step is to attach the bearings, the small bearings, to the guide bearing 3D parts. So to do this, we're going to use some 1/4 inch long number 6 screws, and we're going to place the small bearing over the screw and then screw that bearing into the small holes on the guide bearing 3D printed part. Now when you're doing this, you want to make sure that you're not over tightening the bearings. Now what this means is that you should be able to rotate the bearing with your fingers after you're done tightening. If you're unable to rotate the bearing, you need to slightly loosen the screw. Now we need to cut 3 pieces of our 6mm carbon fiber tube for our main chassis. Here, I cut these pieces to 55 centimeters long, and if you don't have a launcher already built, I would recommend cutting them to 55 centimeters long as well. At this length, the vehicle builds to about 75 centimeters long, but again, you can adjust the length of these carbon fiber tubes as needed to make your whatever launcher you have built. Now, after making these or cutting these carbon fiber tubes, we can attach them to the back axle using some super glue. So now we are going to attach all of our other components to the chassis. We want to make sure we attach one guide bearing all the way to where the back axle piece is. We want one all the way to where the front axle piece is, and we want one roughly in the middle. You also want to make sure you include the adjustment arm chassis mount piece in the middle of the chassis as well. Now, where you glue the middle guide bearing and middle chassis mount on the vehicle doesn't particularly matter. Here I measured the position you'll see later in this clip where I measured 20 centimeters from where that front axle mounting piece is, and that's where I glued in my pieces, but you can certainly put them wherever you like. We can now attach our front axle to the front axle mount on the chassis using a 16mm long M3 bolt and an M3 nut and a lock washer. You want to push the bolt from underneath the mounting piece up into the front axle piece, and then you want to tighten the M3 nut on the bolt with a lock washer in between the hex nut and the 3D printed part. The lock washer helps prevent unintentional pivoting and slippage of the front axle. Now we can attach the wheels to the front axle hubs using some snap ring pliers and the snap rings included with the T61 hubs. So now we can use some hex nuts and lock washers to attach 2 of our 3/16 inch bore T61 hubs to the back axle. Afterwards, we can attach the wheels to the back axle hubs using some snap ring pliers and the snap rings included with the T61 hubs. So now we need to cut a 5 centimeter long piece of our 6mm carbon fiber tube and glue that into the hole on the back axle. This piece of carbon fiber is used as a hook for the string attached to the weight block, and it acts as a way for the launcher to launch the vehicle down the track. Now we need to cut 2 pieces of our 3mm carbon fiber tube to make 2 arms that link the front axle to the chassis and can help us adjust the angle of that front axle. To determine the length of carbon fiber you need to cut, measure the distance between the mounting hole on the chassis to the corresponding mounting hole on the front axle. Then subtract 6 centimeters from that distance. In my example here, the point-to-point distance of the mounting holes on my vehicle is 25 centimeters. So I had to cut 2 19 centimeter long pieces of the 3mm carbon fiber tube. After cutting these pieces, we can then glue the carbon fiber tube onto the 2 different adjustment arm heads. And then using two 12mm M3 bolts, four 12mm M3 bolts, two M3 hex nuts, and two M3 lock washers, we can attach the adjustment arms to the chassis and the front axle. So now we can assemble the backstop, and for this step we need two 4.5cm long pieces of a 1/4 inch dowel cut. And we also need a 9cm long piece of the 6mm carbon fiber tube cut as well. Then what we're going to do is we are going to glue the two wooden dowels into the two face holes on the wooden backstop. And then we're going to glue the 6mm carbon fiber tube into the center hole on the wooden backstop. Afterwards, we can glue the other end of the 6mm carbon fiber tube into the front axle mount. Now we can assemble our braking system, and the first thing we need to do is we need to screw a 1/4 inch long number 6 screw into the hole on the front axle mount piece. Then we can tie a piece of latex tubing onto that screw we just put into that front axle piece. Now, the length of the latex tubing can depend on whatever you'd like it to be. You ideally would like that latex tubing to span from that screw to at least the midline of the chassis of the vehicle. Here, in my example, I'm using a latex tubing that is about 25 centimeters long. So if you're building a vehicle that you use 55 centimeter long carbon fiber of the 6mm carbon fiber tube to make your chassis, then 25 centimeters of latex tubing would work just fine. So here I'm just going to make a quick mark on where I want to attach the other piece of fishing line that will eventually connect to the back axle. So here I just marked where the piece of elastic tubing meets the adjustment arm mounting piece on the chassis. And then I'm going to come in with my fishing line, make a knot on that piece of elastic tubing, and I'm going to use a very long piece of fishing line so that I can also attach it to the brake on the back axle. Before we attach the string to the brake on the back axle, we first need to make sure that the hex nut that sort of houses this brake piece is all the way up towards those two hex nuts at the center of the back axle. Then we can push our brake piece all the way up to that hex nut we just moved, and then tie the fishing line very tightly around that brake piece. And we can use those two notches on the brake piece to help guide where we should wrap the fishing line on that piece. If you've completed this step properly, then when you pull the brake piece off of its hex nut, the brake piece should recoil back onto that hex nut. If your brake piece does not recoil all the way back onto the hex nut, then it's best to redo the knot or the fishing line that connects that latex tubing to the back axle. So now we are going to be attaching the wheel dowel to the back right wheel, not the left wheel, the back right wheel. When doing this, you want to make sure that the 0 is oriented so that it is pointing all the way up when the wig nut is as far as it can go. This dial is used to help you count rotations more effectively when you are setting up your vehicle at the competition. So the last step here is to just mark the position on the wheel that corresponds to 0 on the dial. This makes it easier to count whole rotations more quickly. So at the competition, if you're counting up to 23, 23 and 7/24 of a rotation, you can use that black dial to count all the way up to 23, and then use the actual dial itself to count the extra 7/24 of a rotation. And with that, your scrambler vehicle has been successfully built. Please check out our other videos on how to build your launcher and calibrate your vehill. With that, thank you for watching and stay unfazed.